Alright, so last week I got back into coding a little bit. I don't code anymore in my day job, but it's basically a way for me to relax. And the funny thing is, soon after I looked at the code, within about 5 minutes, I was able to understand an issue that I couldn't understand a few months before. Funny how that works. But basically, the piece of code was trying to calculate the total size of a directory, and I was getting different readings from a Linux utility and the code that I had written. So obviously, there's something wrong with the Linux utility, right? Basically, the requirement was to get the same output as du-p1, which is a utility that you use in Linux to get the size of a directory or a file. So if I run du-p1, that gives me a count which indicates the number of blocks allocated on the disk, and -b1 here means do the calculation in 1 byte increments in blocks. So the requirement here was to get the same output, and my first thought was to try and see how du does it. So what I did was to feed the same execution through strace, which gives you the output of system calls that process makes. So by going through that, I was able to understand that there is a system call that goes out to new fstat80, and the path that I specified is being fed to this system call. So if we look at the system call man page, we can see that the return structure contains a field called st_blocks, which provides the exact same output I need, but in 512 byte increments, but that's easily fixable. But this is what I'm after. So my first thought was to make the same system call in Rust using the foreign function interface and the libc create. But through a brief Google search, I was able to find that there is a function in the Rust standard library which gives me the exact output that I need. So this one is called this struct is called metadata, and there are trait implementations for different operating systems, and the trait implementation that I'm after is for Linux. And if I scroll down, I can see a function called st_blocks, which gives me the exact output that I need. So this is good. This is what I'm after. So what I'm going to do is to use this function to iterate through all the leaf nodes in the directory tree, and then calculate all of that into a total count and then return. That should be my strategy, right? So I have a new cargo project that I have created here. So I'm going to start coding in that file. So the first thing is I'm going to write a function that given a path will iterate through all the child nodes and then calculate all of them together. So this is going to be a recursive function because I need to be able to feed child nodes if their directories into the same function. So and let's return a result. If successful, I return the sizing on sin64, and if not, any kind of error that I'll raise. Right, so I'm using pathbuff. I'm using pathbuff here because it's easy to pass around, and it's basically the kind of the struct that I used in my implementation as well. And error is errors. Alright, so the first thing I need to do is to declare a variable that will store the total size of this directory, and it has to be mutable because I need to be able to add to it as I iterate through the child nodes. Initiate it to 0. Right, and let's return that if everything goes right. Alright, so first I need to check if this is a directory or not, if this path is a directory or not. I can do that by dir function. If not, then I need to raise an error. So that is just do this for now, but there could be other types of errors that will come in the future. Alright, so if this is a path, then I need to get all the children and then iterate through this. To do this, what I'm going to use is a function called readdir in the standard library. So readdir is a useful function which returns a result containing an iterable that I can use to go through all the children. So if we look at the example, this is basically what we have to do. Passing the path, and this is a result, so I have to force it to give me the OK result or panic, and then I need to resolve the result of the iterable, which is also a result. So let's force that to resolve itself too, and then we are just going to access the path object for this. And I can check if this child is a file or not, and if it is file, I'll calculate the size and then add it to the total size. So how I calculate the size is basically what I showed earlier. I'll access the metadata struct in the path and then invoke the stblocks function. Metadata returns a result, and then right. So to get the stblocks function, we need to import the trait into this scope for the Linux implementation. So this automatically happened with my editor, which imported stdos linux fs metadata ext, which is the implementation that I'm after. So stblocks, like I mentioned, returns a count in U64, but it returns a 512 byte units. So to get the actual number, I need to multiply this by 512. Right, so if child path is a directory, then I need to recursively invoke the same function and then add the number that I get from that invocation into total size. Alright, so I've been writing Python for a few days. Back to Rust. Right, let's fix this. Let me fix this typo. Right, and this. Right, okay, let's invoke this. It looks fine at first. I'm going through all the children. I'm adding the file size if it is a file. If it is a directory, then I'm recursively invoking the same function. Right, let's invoke this on the same src directory that I used on the du command. For that, let me get the current working directory, and then I'll add the src path to it, and then I'll pass that path into this function. Alright, so let's run this and see the number we get. Alright, so we get this number, which, if I remember correctly, was not the number we got when I used du function. So there's something wrong with this, right? So this is what I couldn't find out the last time I tackled with this code, but it was really obvious actually. What's wrong here is basically this piece of code, because if it is a directory, I'm ignoring the fact that in Linux file systems, directories also have a size, not only the files themselves. So this was because I had this idea that directories are just containers and files are the actual stuff that, you know, takes space on the disk. But for each directory, depending on the implementation of the file system, there is a certain size, a fixed size allocated when you create a directory. So I need to add that into the calculation as well. And how we do that is to basically get the size of the directory through the same function that I used to get the size of the file. So that's going to be where we check if this is a directory, and if it is a directory, then total size should be incremented by the size of that directory. So that is access through metadata, and then I use st blocks, and st blocks returns the size in 512 increments. Right, so if we just make this change and run the tool again, we get the same output as du. Right, so there is another detail that you might be interested if you're working on this domain. Now du by default does not calculate the size of the symbolic links because it's almost negligible. The size of a symlink is basically the size of the file name that it points to, so it can be negligible. But in our case, this file check here basically is true for symbolic links as well. So we need to add another check that says it's not a symlink. But this would be the most accurate implementation if I'm going after the same implementation as du-b1. But that's basically it. That's how I was able to fix an issue that I had for months just by looking at the code after a few months of a break. But that's how coding works apparently. So I hope that was useful, and if you enjoyed this video, please like the video, subscribe if you haven't. I'll be making similar content in the future, but for now that's it. Thank you so much for watching, and I'll see you next week.